S is equal to n divided by 2 multiplied by the sum of A and L. And they want you to solve for the letter A, which means your goal has to be to get that A by itself. Something to keep in mind, what this next to this means is multiply. Okay, we are multiplying n divided by 2 by this. So we can actually treat it as if it is something like this. So the 3x here kind of mimicking n divided by 2 times A plus L. I know you're thinking, well, wait, that's two separate pieces and that's a fraction, but you can still treat it as if it was the same. So in this universe, we would divide by 3, giving you an end result of 4, and now we're done. But over here, we can divide by either of these two components. Now I'm going to suggest that we divide by this piece right here because our goal is to get this extracted or by itself from all the rest of this, not add more junk to it. Okay? So instead of dividing by n over 2, we can't divide by a fraction, we can multiply by its reciprocal, which is 2 over n. Okay? And 2 over n. Okay, so we're multiplying here and here. Leaves us with cancellation because n times 2 and 2 times n cancels itself out. Leaves us on the left with 2 times s over n times 1. You might have forgotten that s by itself means s over 1. We just don't ever really write that. 2s over n is now equivalent to what's left of A added to L. Now it's not too hard to get that A by itself. What do you think we can do to get the A by itself now? Subtract the L. Yep. Correct. 2s over n, all of that, minus L is equal to A. The book has a slightly different answer, but when simplified, it's this. The book just doesn't show you. But this is correct. That's 15. Moving on to number 17. And I feel like this component here, how you have to divide out a piece, is one of the harder things that you'll see in these. 17. A is equal to V minus U divided by T, and they want you to solve for V, which is this. They do? Oh my gosh, I looked right above. Yep, thank you. Thank you. T. Okay. So we want to somehow get T by itself. What is the easiest way to get there? Does anybody have an idea of a first step at all? Sadie, go. Yep. I would multiply actually by T over 1. Because what that's going to do, even though it seems weird, it's going to make it multiply by T over 1. AT is equal to V minus U. It's easier to separate these two pieces than it is to try and mess with the V and U. to get that t alone. Very good. By multiplying by the t, we just eliminated the denominator of that fraction. Think of it as 12 is equal to x over 3. What we did here is equivalent to the multiplication by 3. Okay, that's the equivalent step. But instead of solving for x, we're solving for t. What's our last piece going to be? We want to separate the a and the t. Divide by a. Good. So now the a divided by a is equals to 1. T is equal to whatever v minus u is divided by a. Yes. I don't know if clever is the word I use, but we'll get her done. Okay, just a couple more. And some of these, just to be honest with you, some of these, there's different ways to get there. They might require more steps, but I always try and go with what I think is the least amount of steps. But you might end up getting there over the river and through the woods instead of by the expressway. It doesn't matter. You'll still have the same answer. So this is 19. V squared is equivalent to u squared plus 2 times a times s, and they want you to solve for s. So somehow we need to separate the s from 2 times a, because it's 2 times a times s, and this positive u squared. So if this u squared is positive, what can I do to get it out of here? Subtract it. Good. So now I have v squared minus u squared on the left is equal to, these become a 0, 2 multiplied by a multiplied by s. This is just like 3 times 4 times x, or 12 times x if you were doing something like that. What can we do with the 2 and the a to try and extract it from the s? Divide it away. Since it's 2 multiplied by a multiplied by s, if I perform the opposite, which is division, I extract the 2a from that. 2a divided by 2a is 1, so 1s is equivalent to v squared minus u squared divided by 2a. That's 19. (21). This is another fraction situation. The way Sadie answered the other one would work for this one as well. 21. S is equivalent to a over a minus r. Solve for r. Which right now our r is a negative r, but we'll fix that. So this is like a fraction. 49 is equal to, I don't know why I always go this way, x divided by 2. So to isolate r, or get that somehow by itself, it's easier to get it up here. So we're going to multiply by that denominator, which is a minus r. Ugh, this one's pain. Multiply by a minus r over 1. Multiplied by a minus r over 1. S times a minus r This one is a pain. Equals A. You had to get it out of the denominator. There's just no real good way around it. Ugh. Okay. When you have something that's in the denominator and that's what you want, you got to get it out of the denominator. Distribute SA minus SR is equal to A. Yuck. Getting there though. There's our R. What can I do with this SA to try and get it away from this SR? Well, since it's an addition, SA, I'm going to subtract it. I know. So now you've got a negative S multiplied by R is equal to A minus SA. Now if we divide out our negative S, this one's hard. It's just a lot of work. I now have R equals A minus SA over negative S. You don't really have to do anything else with it. You can leave it like that. You don't have to mess with that negative. Just leave it just like that. All right, just a couple more, guys. This one was a lot of work, but if you have what you need is in the denominator, you have to get it out of the denominator first. It's the easiest way to clean it up. Just take a little while longer. You might have also, I don't know if any of you saw, but when there's a negative and a negative, you can like take this and distribute it out. But you know what, I'm not even going to show you that. 23. Ugh. Okay. I know these are tough, but I really want you to be able to recognize how to do the work to get there. F is equal to, oh boy. Okay, watch out. We've got little f and big F. Big F is equal to whatever FG little is, F plus G minus D. And they want us to solve for D. Oh, goody. The D is located in the bottom again. So what do we have to do with when what we want is in the denominator? Multiply by all that, yep. Which is F plus G minus D over 1. Same thing over here. F plus G minus D over 1, which is going to give you this big ugly thing of F times F plus G minus D. You don't have to write the over 1. FG. Okay? We're still trying to solve for the D. Same second step as what we did last time. What did we do last time? Yep. Big F, little f, added to big F, little g, minus big F, little d. That should be a G for that. Still trying to get that D by itself. We're almost there though. What can I do with this positive FF to get it over there? Yep. As long as I'm at it, what can I do with this positive FG to get it over there? Yep. So I am now left with, on the left, the negative FD, lucky for us, we can divide out that F, is equal to FG minus FF minus FG. If I divide by a negative F, I now have my D by itself. So D is equal to FG minus FF minus FG divided by negative F. And if you used this negative F to flip, you would flip all the signs and all this. But if you left it like this, it's still the same thing. Like the book answer is negative FG plus FF plus FG over F. Because they took that and flipped all these signs with it. That is a lot of work. Goodness. That was 23. Tell you what, I'm going to have you guys stop at, I don't want to do 25 and 27 with you guys. I think those are too much. I'm going to have you guys stop at 24. Okay, so I'm going to